Good. So it's a great privilege to welcome an old friend of the Faraday and of me personally, I have to say, to our seminar today. This is Professor Andrew Briggs. Andrew has very strong roots in Cambridge. He did his PhD here. His father actually was the headmaster of the King's School, King's College School, or King's School it's called, isn't it, for many decades, and probably known to some here. I remember taking Andrew's parents into college for a guest night once, and his father was already, I think, well into his late 80s by that stage, and he looked around and can identify, at least sort of 6 or 7 of the fellows. They were old students of his, and remember what they had done and their CVs. It was quite remarkable, really. So I'm sure Andrew has inherited that fine memory. But after doing his PhD here, Andrew went back to Oxford, also did a degree in theology here. I went back to Oxford, I think, never really looked back after that, and is now a professor in materials. He's also director of the Quantum Information Processing Interdisciplinary Research Centre, as well, in Oxford. And as I said, he has this book coming out in January 2016. I was chatting with somebody just before the seminar who mentioned that the reason they come to the seminar is they didn't know what it was about, and therefore they were curious to know. And I'm delighted by that, because we were worried that perhaps the title might put people off, obviously, and that's not the case, but it's aroused already curiosity. And so we're delighted that Andrew, who tells me he's going to give this talk for the first time to us, so we are all in an experimental incubator today. Thank you, Andrew, very much for speaking to us.
Well, Dennis, thank you for that marvellous introduction, after which I can scarcely wait to hear myself speak. As Dennis said, I grew up in Cambridge, went to Oxford as an undergraduate, and then came back to Cambridge for my higher education. I love this concept of people dozing off. You may know the story of a talk rather like this one, where someone sitting just about there dozed off and started to snore very loudly. And so the speaker couldn't take it any longer, picked up an object from here, threw it at the person, who was heard to say, "Throw another one, I can still hear you." Well, I want to tell you today about the penultimate curiosity. And the clue is in the subtitle of the book that I've written with Roger Wagner. It's how science swims in the slipstream of ultimate questions. So you have this sort of picture of the ultimate questions swimming along, and science is swimming behind them. Or if you want to take it another way, you see birds flying in a sort of V formation in the air, and the bird who's at the front of the V has to do the most work, and then the birds behind find where there's an upcurrent. And there's this sort of penultimate curiosity that has gradually come to have some sort of recognizable identity, which we label science, which is flying along in the vortex of these ultimate questions about things that may lie beyond the rim of the visible world. And there's been a rather nice study recently of the bald ibis.
How birds fly, and particularly birds that fly in V formation. And it's simply because you look up to the sky and you see these birds in this such an organised state that you instantly go, how are they doing that? Why are they doing that? Theories range from a traditional, the more birds the better, if a predator comes along and picks one off, it's not going to be me. There's an idea that the birds at the front might be better navigators, and another one that's really persisted is this idea of an energetic benefit to flying in a V formation, that for those birds flying at the back, they're not having to work as hard during the flight. The first really interesting result that we got off the loggers was that the birds were locating themselves in positions within the V formation that was completely predicted by fixed wing aerodynamics. And what we mean by that is they were positioning themselves in the best possible spots to take advantage of the good air, the upwash coming off the bird in front.
So I want to try and convey how this sort of penultimate curiosity has come over time to fly in the vortex of the ultimate questions in front. And I suppose a starting place is my Cambridge childhood, and this is Free School Lane. I'm indebted to Ruth Bankiewicz for this picture that she took recently. And if you've ever walked down Free School Lane when the doors to the Cavendish are closed, you'll see this inscription over the doors of the Cavendish. Here it is carved, almost certainly at the instigation of James Clerk Maxwell, Magna opera Domini exquisitata in omnes voluntates eius. And you can translate that as the works of the Lord are great, and they're sought out by everyone according to his pleasure. Exquisita there is the same Latin word that we get exquisite, and also inquiry. Quire, it's the same root. So it's this inquiry according to God's pleasure. And we'll come back to that towards the end of my time with you this afternoon. Around about the same time as the Cavendish Laboratory was going up in Oxford, the Museum of Natural History was going up in as the Cavendish Laboratory was being built in Cambridge. People have lost their heads for smaller mistakes than confusing Oxford and Cambridge. In Oxford, the Museum of Natural History was going up, and the carvings there are quite exquisite, if you've ever studied them. And they were studied by this Irish stonemason, O'Shea, but he started to have a fallout with the authorities at Oxford. And in the end, he got so cross that, well, the results of him getting cross... Has anyone been in the Oxford Museum of Natural History? Have you ever looked up? And do you know why, on one side, the stonework above the door is just, you know, nice and smooth as you'd expect it, and the other side it's all rough hewn? Does anybody know why? It's because of this argument between O'Shea and the university, and he got so cross that he started to carve caricatures, sort of spitting image caricatures, of members of the congregation in the form of parrots and owls. And he was told to remove them, so he did. He knocked them off, and nobody has ever made it good since then. In 2009, there was a debate held in the museum there between Richard Dawkins and John Lennox. And in the course of the exchanges, Lennox asked Dawkins whether the motivation behind the building of the museum had not been in part religious. And Dawkins replied that it had not, and the debate moved on. I'm sorry, I've just lost my mouse. Let me see if I can make this work. And the debate moved on. They were both wrong. And they were wrong because they didn't know actually that a lot of the money for the building of the Museum of Natural History had come from actually the sale of prayer books and Bibles by Oxford University Press. But also, if they'd looked up above them at just that, above the entrance, has anybody ever looked up? Anyone who's been in? Do you know what's there? So let me show you an enlargement of it. And here's the picture, and it's an angel, and the angel has got in one hand something like a large petri dish with 3 biological cells in it, and the other hand a Bible. And it was put there to signify the intentions of the founders of the museum, whose desire it was to bring future generations of men to study the open book of nature and the mystery of life under the guidance of a higher power which alone could enable them to read the pages of that book with right understanding. And the picture of the museum, the photograph there, which is a photograph from the 19th century, was actually taken by a great-great-great-uncle of Roger Wagner. It was taken by Henry Wagner. Now, one of the great things about... Are you asking a question or scratching your head? One of the great things about working with an artist is that it helps us to look back at the earliest recordings, or the earliest recorded evidence of human curiosity. And if you were asked to say, what would you produce as the earliest evidence, physical evidence that's now available of human curiosity, I'd be very interested to know what you'd choose. You can tell me after, or we could talk about it in the discussion. But we chose cave paintings because these are evidence which, you know, by definition has survived to the present day of curiosity long before the time of written script. Here's one that was discovered in 1875 when Don Marcello was excavating a cave near his estate in northern Cantabria. And with his daughter Maria, he wrote, "Suddenly I made out forms and figures on the ceiling." And she cried out, "Look, Daddy, oxen." And there was a painting of oxen. And of course others have been discovered since then. Some very famous ones were discovered at the Leso cave in September 1940. In that case, the public was allowed to go into the cave for about the next 20 years. And the human breath and so on and things that they brought in started to cause damage. They stopped letting visitors go in. They installed an air conditioning system, which, sad to say, did far more damage than ever the human visitors had. And now those paintings are damaged almost beyond repair, actually. More recently, a cave was discovered in Chauvet. That was discovered in December 1994. And we've chosen a picture from the Chauvet cave for the cover of the book. So this is the wraparound cover of the book. And a lovely thing about working with Roger is he's competent to give a sort of professional appraisal of the paintings. And he reckons that these are successive paintings, are getting better and better until by this fourth one, which is the one that's on top, the level of anatomical verisimilitude is the sort of thing that George Stubbs and other horse painters would not have been ashamed of. And you cannot, I think, paint that carefully and that accurately unless you're pretty curious about what it is that you're looking at and what you're studying. And a lot of people feel that on the basis of this evidence and lots of other evidence too, particularly from South Africa, there's an intimate relationship between this sort of curiosity about, in this case, animals, and the kind of curiosity about religious things, curiosity about God. The Chauvet cave has been closed to the public almost since its discovery, but to give people the experience of seeing these paintings in the cave, they built a replica. And the replica was opened about 2 weeks ago. And the BBC did a little film of it, and I'll show you a clip of that in a moment. And the clip will end with an interview with Jean Clotte. Now, Jean Clotte is the leading cave scientist, cave painting scientist, who studied these paintings. And he's been terribly helpful to us in writing the book. We've had quite a lot of correspondence with him. He's helped us to get the facts right. And he's also given us a number of his own photographs of the original paintings to use in the book. And he was terribly sweet. He said, "There's no charge, but please could he have 2 copies of the book?" And he certainly can.
Are there skins in the south of France? We're making a journey to the most important prehistoric
Can you hear
sites
all right?
ever discovered. This place was discovered by cavers in 1994 and then closed off to the public immediately. Very few people have ever been allowed in, but it's absolutely spectacular. It's not only the ancient footprints and animal bones that excite archaeologists here. The most important features of this cave are also its most breathtaking.
Right. Sorry?
Hundreds of images adorn the walls.
Sorry, where
mostly
is it?
of animals. Drawn with charcoal and red ochre, they're surprisingly sophisticated. The artists seem to have worked with the contours of the rock. They're so well preserved, they look as if they could have been drawn yesterday. But radiocarbon data has revealed that they were painted 35,000 years ago by our early human ancestors. It's some of the oldest art ever found.
The people who live inside this cave, they live outside. And they went to the cave for the ceremony to draw those animals, which were power animals. And the cave was a place which was charged with that supernatural power. And we know about that because very often they use the natural reliefs, the cracks, the bumps in the cave to draw the animals. For them, those animals were inside the wall, ready to appear.
In July this year, Roger and I are going to make a trip to some of the locations that we associate with key moments in the development of the penultimate curiosity. So the Chauvet Cave that I've just shown you is up there. Pisa, associated with Galileo. Athens, obviously, people thinking about curiosity. But the next place we're going to is, depending on how you pronounce it, Miletus, now in the west of Turkey. And that was a real turning point in curiosity. And it hinged, amongst other things, on the development of script. So a lot of the writing before the time that I'm about to tell you about, sort of 6th century BC, in this part of the world, was in Linear B. It had been in Linear B since about 1300. And that was a terribly difficult script to write. You needed to be a pretty sort of competent civil servant. And so very few people were able to use it. Eventually Linear B was decoded, and everybody was terribly excited and curious to see what new ancient wisdom would they discover from Linear B. And the result, well, it was rather as if you'd discovered the writings of the records of St. Edmund's College, and all excited to find out what they were. You discovered eventually that all they were was about accounts for meals and things like that, because most of the Linear B accounts were just about counting sheep and so on. But this jug here and a drinking cup that goes alongside it marked a new point, because this is in Greek alphabet, and it introduces an alphabet that ordinary people, relatively ordinary people, can use to write. This particular one on the jug, it says, "Whoever of all the dancers performs most nimbly will win this jug as prize." And there's another one on the associated cup that says, "I am Nestor's drinking cup. Whoever drinks from this cup, the desire of the fair-crowned Aphrodite sees him." So people are beginning to have available to them an alphabet that they can use to write ordinary thoughts, as it were. And this thriving port of Miletus is now marooned several miles inland. There's a marble lion, one of a pair that once guarded the harbour entrance, that now looks out over the field of waving cotton. And overlooking the harbour, you've got this boulaterion, or council chamber, and then beyond that the impressive 4th century theatre. And those are among the few easily recognisable buildings that remain. And in the theatre you have inscriptions on some of the seats for the Jews and God-fearers. And this was the place of the goldsmiths of the blues. And these are haunting traces of the rich cultural life that once existed in the city. And though these appear slight, they provide a clue why this radical new kind of curiosity developed in the place. And in particular, there were writers there of the time. Not much of the writing remains, but we know a bit about it from subsequent commentators and so on, who seemed to be able to draw together the best of the thinking from further west of there, Greece and so on, and the best of the thinking from further east, and start to ask new questions. And one of the questions they asked was, where did everything come from? Where did everything come from? What was this arche? And so you see this sort of emerging curiosity, this record of emerging curiosity. Where did it come from? And was there a unified source of it all? Now, in a minute I'm going to tell you a little bit about how these questions started to separate out. There's a virtue in the unification of this curiosity, but it carries a risk. And the risk that it carries can be illustrated from another example of slipstreaming. This is a peloton in a cycle race, and what the riders do is they try to get as close behind the rider in front as they can, so that the rider who's behind doesn't have to work quite so hard in order to cycle at the same speed. And actually in a team they will swap places in the peloton and swap them so that different people take turns to do the most work, just as indeed the birds do, flying in the V formation. Now, if you think of this metaphor of the penultimate curiosity benefiting from the slipstream of the ultimate questions, what's the risk? Well, the risk is that you might get too close. And if you get too close, you get what's called a shoot. And this was a very famous shoot that occurred on the 8th of September 2005. And you can think of one or two times in history. They're rarer than most people would think, actually. But you might think of the incidents in Italy in the 16th century with Galileo and so on. However much that may be one of these cases where much more is known than is actually the case. Nevertheless, there may have been a sort of risk of people getting too close. It may have been actually that the church was too enthusiastic about science, but about previous science, and wasn't completely up to date. So it was not that the church was anti-science, but it wasn't as up to date as it should have been. Anyway, you can get the shoot. So this slipstream brings with it just a little bit of a warning that you don't overdo it. But nevertheless, if you can get it right, it's terribly productive. So now I'd like to show you a place that would have been next on our itinerary in July, and this is Alexandria. And you may know that 10 years ago, in 2005, there was some new discoveries in Alexandria of about 20 lecture theatres. And although the evidence is indirect, these may be lecture theatres from the 5th and 6th centuries, and they may be lecture theatres where two students of the time studied. One of them was Simplicius, and the other one was Philoponus. And Simplicius was a great advocate of actually associating, as it were, the upper heavens with God himself. So he deified the upper heavens and said, well, they must be made of sort of different kind of stuff from what we've got down here. John Philoponus thought that was quite wrong. Here we've got this guy in the 6th century AD, at a time when you think, well, not very much was happening then. Well, actually an awful lot was happening. And John Philoponus was quite willing to challenge the accepted science of the day, which by and large meant challenging Aristotle. And he had quite a sense of humour, so he took Aristotle's idea of how a javelin flies. And Aristotle's idea of how a javelin flies was that a javelin would naturally come to rest, it would naturally slow down because that was its resting place. But what stopped that happening was that the air from the front of the javelin would rush round to the back and push the javelin forward. And John Philoponus had the courage to say the king's got no clothes on. He said, that's stupid. And the particular way that he said that's stupid was this. He said, if Aristotle was right, then you wouldn't need soldiers to throw javelins. What you do is you rest all the javelins on a wall, and then you get 1,000 bellows, he said, 1,000 pairs of bellows, and you just sort of pump like that. And under this air pressure, the javelins would whoosh off and attack your enemy. And he created the idea of impetus, so what we would now call momentum. And you can see that in many ways he was sort of foreseeing what Isaac Newton was to articulate mathematically here in Cambridge 11 centuries later. And at least at this level, Philoponus had got there first. And it seemed too that he had to sort of fight things on two fronts. One was university authorities sort of saying that philosophy was a waste of time and money, you know, and it wasn't contributing to the ref exercise, and they should kill it off. And then simultaneously, it seems he was being attacked by the church for not taking a sufficiently literal interpretation specifically of Genesis. And in his commentary on Genesis, he says, look, you know, it's not telling us about stuff and so on, it's telling us about other things. So here he was in the 6th century, beginning to separate out this penultimate curiosity about the natural world from the ultimate curiosity of religious questions. And against Simplicius, he quite specifically said that, you know, the universe is all, it's all sort of one. And it's separate from God, and so you can study it as God's creation. Well, the next place on our tour, well, there are 1 or 2 places around the Mediterranean, but we have to come to Oxford in the 13th century. And the first Chancellor of Oxford was Robert Grosseteste. The picture there on the left is a picture of him as Bishop of Lincoln, which he went on to be after his time at Oxford. And the picture on the right is from Grosseteste's work, and it's optics. It's showing light from the sun on the left there. Okay, I don't know if you can see this, being refracted by a spherical lens. And it's part of a collection of manuscripts by a number of authors gathered by Roger Bacon. And recent studies, particularly by people in Durham University, have uncovered the way that Grosseteste's understanding of light was actually rather modern. And that where people had thought that he had got it all wrong, it was because of corrupt subsequent manuscripts of the Latin. And as people get back to the earlier, less corrupt manuscripts, it turns out that Robert Grosseteste was getting it more and more right. And, you know, 4 centuries before Isaac Newton, Grosseteste was talking about gravity, and 7 centuries before the Big Bang Theory, which Martin Ryle here in Cambridge was such an advocate of, he was talking about a single origin of the universe like that. And he was creating the whole kind of way that we pursue curiosity. Because both in his studies of the scriptures and in his study of the natural world, he was giving people permission to open their eyes and look for themselves. So by contrast with the bestiaries, where you just copied what the previous person had drawn, he'd go and look at frogs and draw them for himself in the woods around Oxford. 4 centuries later, I should mention that one of his students was called Roger Bacon, not to be confused with the other Bacon, Francis Bacon, 4 centuries later, who also has an association with Oxford. And here are some pictures, title pages from 3 successive books by Francis Bacon. The title page of The Advancement of Learning depicts a ship on the sea with a quotation from the book of Daniel. Many shall go to and fro, and knowledge shall be increased. The title page of Silva Sylvanum, published after his death, shows the globe of the intellectual world resting between the pillars of Hercules, which represented for classical writers the edge of the known world, the ne plus ultra, beyond which there is no more. And then the third one here, the Novum Organum, those 2 images are combined in the picture of a ship plunging through the pillars of Hercules, voyaging to discover worlds unknown to classical antiquity. And in a similar way as that, Bacon believed, well, he wrote that by distant voyages and travels which have become frequent in our time, many things have been laid open and discovered which may let in new light upon philosophy. And what Bacon helped to do for science was what was already happening with reading the Bible. And that was giving people confidence to read the Bible, the Lollards and so on its own terms. Just open your eyes and read it in its plain sense, and be confident that you can read it and make sense of it for yourself. Now, by the 16th century, there were 4 pretty well established levels of allegorization. There was the literal sense, the obvious historical sense, the moral sense, showing us how to live, the allegorical sense, pointing towards timeless historical truths, and anagogy, the heavenly sense. And if you were going to read the Bible, you had to be competent in all these 4 levels, and you can guess who the professionals who were competent. And that was beginning to be stripped away, and people were beginning to read it for themselves. And what Bacon and those who came after him did was the same thing for the world around us that we can study, the natural world. So Bacon was beginning to show that natural objects were designed for their utility rather than their meaning, and creatures were not symbols to be read, but objects, or objects to be used, but to be investigated for their potential application. Sorry, there's a typo there. They were objects to be used or investigated for potential applications. So what was going on then was removing these levels of allegorization, examining primary data for itself, recovering prelapsarian knowledge. One of the motivations for science in the 17th century in Oxford was a belief that Adam, before the fall, had had perfect knowledge, and that part of redemption was to recover that perfect knowledge that Adam had had. And crucially, to test hypotheses by observation. That was inherited from Robert Grosseteste, who had emphasized the need for doing that. And the reason he said you had to do that was that your own sort of emotions and feelings were unreliable. And you needed to have these objective ways of testing the hypotheses that you developed. So as the 17th century went by, you had various people contributing to this endeavor of what we're calling the penultimate curiosity. So take the whole thing of pumping water. Galileo knew that water couldn't be pumped up by suction from more than about 34 feet. And then 2 other Italians had this concept that air has weight. Boyle was doing experiments, as so often in science. He was able to do better science because he had better apparatus. Those who have the equipment and the materials can do the science. And he had a better air pump than other people. And he discovered, as anybody did who operated the air pump, that the air's springy. And if you've ever tried to pump up a bicycle tire when the valve is closed, you'll know that you pump and the pump springs back at you. And so Boyle started to put all these things together to investigate what became known as the springiness of air. And in the process, he did various experiments, including the J-tube experiment that led to what we now call Boyle's law, or tested what we call Boyle's law. You have a J-tube, and it's sealed at one end, and you have some air in it there, and you have some mercury, and you compare the length of the air column with the difference between the heights of the mercury here and here. And now look what he's done. He's got his laboratory notebook, and here are the columns, A to D, of the experimental observations. And now column E is what it ought to be according to his hypothesis, the hypothesis that we now call Boyle's law. And there's no cheating. So he's put down the actual numbers, and they don't quite agree. And then there's a great discussion of experimental error. And do these numbers validate or falsify the theory? Which is it? Because they don't agree exactly. And he discusses all that. And so now the kind of thing that we scientists learn as part of our apprenticeship is being formulated by Robert Boyle and giving precision to this penultimate curiosity. One of the great heroes of the time was John Wilkins, who was warden of Wadham, and he gathered what we would now call the weekly seminar in his rooms at every Thursday before 2 o'clock. And they included names that you recognize: Robert Boyle, Robert Hooke, Edmund Halley, Christopher Wren, and others. And here's the title page of Robert Boyle, the Honourable Robert Boyle, Fellow of the Royal Society, the Christian virtuoso, showing that being addicted to experimental philosophy, a man is rather assisted than indisposed to be a good Christian. Well, if we fast forward, we have to include in Oxford the 1860 debate, although I think that Darwin probably has a closer affiliation to Cambridge than he does to Oxford. And I'm not going to go into that now, partly because time is short, except to say that this is the invitation to an event that we had last year in our garden of a play called Mr. Darwin's Tree, which some people may have seen here. It's a one-man play acted by Andy Harrison, written by Murray Watts, and it's got some wonderful, wonderful lines in it. So, for example, when they tell the story of the alleged story of Huxley riposting to Wilberforce that he would rather be have a monkey for an ancestor than be associated with a man who has used great gifts to obscure the truth, Murray Watts' little comment is, sounds like the answer you wished you'd thought of at the time. Around about the same time that that debate was taking place in the Museum of Natural History, an experiment was being made. And in 1857, 2 years before the publication of The Origin of Species, a group of 4 people met at the rooms of the Royal Asiatic Society in New Burlington Street to determine the results of a dramatic experiment. And it was that they'd got 4 sealed envelopes with 4 different translations of a previously untranslated text. And the experiment was to see whether the 4 translations were the same, which would give some credence to the interpretation of the text. The text had been discovered up here in the west, what's now the west of Persia, the west of the ancient Babylonian Empire. It became known as the Behistun inscription, and here's a close-up of the inscription. And the marks here are because, you won't believe this, but the Allied soldiers used this as target practice for shooting in World War II. And this is some of the damage from using it as target practice for shooting. This is a bit closer up what it looks like. And when so here are the inscriptions, and there's a man, you can see they're pretty big. And when the seals were opened, 3 of the translations were almost identical. And the 4th one that wasn't quite identical was by a German who lived in France, and a lot of the differences were attributed to his poor English rather than his poor understanding of the original text. And 2 of the translations by Rawlinson, who's the guy who transcribed all this, and Hinks often agreed word for word. And I tell you this story to emphasize that the penultimate curiosity that we call science is part of this larger curiosity, or if you like, swims in its slipstream. And if we're going to make progress in ultimate questions, we need an intelligent openness to all different kinds of inquiry and all different kinds of evidence that come our way. And around about the time that Darwin and others were doing this great thinking about mechanisms of evolution and discovering more and more about how species evolve and other aspects of science, so too more and more was being discovered about ancient Near Eastern texts, which provide fantastic background to how we should read them and enable us to pursue those kinds of inquiry more intelligently than would otherwise have been possible. One of the great things about working with Roger is enjoying some of his marvelous paintings. This is one of his paintings from a series called Out of the Whirlwind, which is some studies in the book of Job. And as so often with Roger's paintings, the real key to the painting, the real subject of it, you have to look for. So the whirlwind's pretty obvious to you, but there, that's what the painting's all about. It's Job, and Job in dialogue. Here's another picture of Job in dialogue. And this, you know, the book of Job, the writer of Job is a sort of hero of the penultimate curiosity. Because there he is, he's willing to ask well over 100 detailed questions about the natural world in the context of the ultimate questions about the meaning and purpose of life and where suffering and theodicy fit in. And so we have one of Roger's pictures in the book, and he insisted that we put something of mine in about my own curiosity. This is the only science result that I'll show you today. And it's an experiment that we did to investigate, well, its technical name is the Leggett-Garg inequality. The Nobel Prize winner, Tony Leggett, who got a Nobel Prize for low-temperature quantum physics, had done his first degree in classics and never lost interest in the rigorous ways of pursuing ultimate questions, in particular the nature of reality, which is thrown up in the air by quantum mechanics. And rather than just sit by the fireside sort of arguing about it over a beer, Tony Leggett developed this rigorous mathematical inequality, which for 25 years was so hard to test that nobody could think of an experiment. And then we've done a series of experiments in my lab, and this is the second series of experiments that we did. And it enables you to test experimentally particular philosophical interpretations of reality, and indeed to rule out one particular interpretation of reality. So it's amazing that these ultimate questions are not only raised by the penultimate curiosity of science, but science also provides a way to answer some of them. Well, I have to come back to Cambridge and back to the Cavendish laboratory where I started. And there's a picture of Clerk Maxwell, James Clerk Maxwell, as a boy. And on the left is a diagram from a paper that he wrote as a schoolboy, which was read at the Royal Society of Edinburgh. And some of you here may have, as kids, you know, if you stick 2 pins into a piece of wood and you have a loop of string and a pencil, you can draw an ellipse. I expect some people have done here. Well, Maxwell did that, but he didn't stop at that. And so he thought, well, what happens if you tie one end of the piece of string to the pencil, and then you pass it round that loop, and then round this one? And he started to draw these additional curves. And then he worked out the mathematical formulae for them. And all this as a schoolboy. And then you may know his next big advance was a mathematical theory that accounted for the rings of Saturn. And then later on, he went on to, well, he was trying to understand electricity. He was trying to understand the experimental work of Michael Faraday and others around about that time. And he was trying to understand the mechanisms. And so he had these pictures of cogwheels and things like that to try and explain electromagnetism. And it didn't work, and it didn't work. And then he was inspired by campanology. And he thought, well, what happens if you're watching people ringing bells and all you see is the ropes at the bottom and you don't know the mechanism, but you hear the sound? Would that approach be helpful? And so instead of trying to develop cogs and things, he just sat down and worked out what we now know of as Maxwell's equations. And I personally think that that advance has made as much difference to our lives as any advances in our understanding of ourselves from Darwin's work and the work of theory of evolution. It's changed every aspect of technology. It led to all electromagnetism, all electrical engineering is based on Maxwell's equations. And it also was what inspired Albert Einstein more than any experimental evidence to develop the special theory of relativity. On November the 1st in 1879, the Reverend William Guillemard, the rector of the Cambridge Church of St. Mary the Less, called at a house in Scroop Terrace, not far from the Cavendish Laboratory. he'd come to bring communion to a bedridden parishioner who at the age of 48 was dying from advanced abdominal cancer. He was told that the patient had had a bad night and he did not expect there to be much conversation. And as the rector robed himself, he was astonished to hear from the bed a Scottish voice with a trace of a Galway accent reciting from memory George Herbert's poem about the robing of Aaron. And that was James Clerk Maxwell, who died a few days later. And the vicar described this terrifically strong faith that came over from this man dying of cancer, which had been with him, as far as we know, from his earliest days, uninterrupted. We don't actually have a picture of the inside of the Cavendish laboratory in Maxwell's time. This is a picture that was taken in about 1900, well, the first 10 years of the 20th century. There's George Shell, who went on to run the Cavendish laboratory for the undergraduate teaching laboratory. A very interesting student at the front of the picture there. And it was almost certainly at Maxwell's instigation that those words were carved on the doors of the laboratory that I showed you at the beginning. I came to the Cavendish laboratory to do my PhD, by which time it had moved to West Cambridge. And I suggested to the head of department, Brian Pippard, that it would be very good to have the inscription over the entrance, but it'd be very nice to have it now in English, because not so many people read Latin. And he agreed to put it to the departmental committee. I only later discovered he was sure they would reject it, and that he was astonished when they thought it was a great idea, and they implemented it. So now if you go to the Cavendish laboratory, this is what you see over the entrance of what's probably the world's most distinguished physics laboratory. And it's actually easier to see it now because they've removed a canopy if you go past there. The doors have changed. This photograph was taken, it was the frontispiece of my PhD thesis actually. The doors have changed, but the inscription is there in the Coverdale translation. And it says, "The works of the Lord are great, sought out of all them that have pleasure therein." Does any of you notice the subtle change that's taken place compared with the Latin inscription? The Latin was the Latin Vulgate translation of the Septuagint, which was probably a slightly corrupt Hebrew text that it was based on. And in the Vulgate, it's God's pleasure. Here it's changed, and this is probably more faithful to the generally accepted Hebrew text, that it's us who are privileged to pursue the penultimate curiosity, that have the pleasure as we swim in the slipstreams of ultimate questions.
Thank you very much, Andy, for that. I'm sure that stimulated some questions and discussions, so over to you for any questions. If you wouldn't mind putting your hand up and then just waiting till the microphone comes so we can record the question. Thank you. That's pretty great. A question over here. Thank you.
I wonder if you might apply your curiosity to the threat of the increasing politicization of science. For example, in the role of consensus among scientists to deal with uncertainty, or do you think it's always been politicized?
Isn't that interesting? You know, the oldest people, you know, in the university world worry that, you know, the students are now customers, you know, and we're delivering a service that they're entitled to ensure value for money and so on. The oldest university in Europe is Bologna, which was founded as a commercial enterprise. And the professors in the early days of the University of Bologna actually had to pay a deposit. And they only got their deposit back if the students were satisfied with the lectures. It's hard to think of a time when you could separate these things, but I do think that you're right, that being able to explain to non-specialists what certainty and uncertainty are all about is terribly important. I gave you a little example from Robert Boyle there, but let me give you a more recent one, which was that Rolf Hoyer, as director of CERN, when 3 years ago they were beginning to get growing evidence for the discovery of the Higgs boson, I thought managed the public engagement of that extremely well. So, you know, initially there was this result with a 3 sigma uncertainty. Now, I don't suppose half the people, I don't suppose many of the people knew what a 3 sigma uncertainty was, except this, that they understood there was a measure of uncertainty. And then later a result was announced with a 5 sigma. Better. You could be more confident of it. And I think this ability to communicate is it's an unfolding understanding of critical realism, in the sense that our scientific knowledge is provisional and is liable to be to convey and communicate.
Thank you. Please, over here. I'm sorry, just 1 second. Thank you.
Very, very fascinating talk. And it was just an observation. Writing his Timaeus. And he says, you look at this world of order about stuff here.
Yeah.
Where does it come from? It must have come from a designer outside the theory of the demiurge.
Yes.
And that, the reason order, rationality out of disorder,
Yes.
man now knows in his rationality, his place. So there's got an ethical. Then along comes Aristotle and says, stuff and nonsense, you don't need the designer because often she sorts it all out. So all you have to do is not go back to your own rationality, but it starts there, doesn't it?
Indeed it does.
It goes back a long way.
And that was a lot of St. John Philoponos.
Yeah.
Philoponos means lover of work, don't you like that? The industrious, he's sometimes called. And so Simplicius was saying, hang on a minute, you know, it's not quite like that.
Question
Bob.
here? Bob, yes?
Thank you, Andrew. Pardon me. You've been living on this border between. I wonder if you could just reflect a little bit on truth as conveyed by sciences, because it seems to me there's differences between them, because observer makes of it, as you point out, you have to look very hard to see what's the real crux of this painting. Message in science is in your face, it's the numbers there.
Yes.
Anyway, I'd be interested in your reflection.
I important, Bob. If you're a nerd like me, you know, I was really a couple of transistors together and get a circuit to work. With the sort of knobs and dials kind of truth. You know, I like meters and things. And that's how I naturally think and how I naturally work. Temptation for me to think that that's the only way that you can know anything. That would be a disastrous mistake to make if I is, and that's the only kind of curiosity that's worthwhile. Happens to be maybe what I'm best. I think that we expand ourselves so much as people if we have respect for other ways that people can investigate it and articulate it, and be in dance or music or any of a number of other creative ways.
Could I do just a follow-up question? Because we had Russell Coburn speaking just here in Cambridge. And one of the questions that was asked of him, as I remember, was what kind of beauty did he see in his nanotechnology in your own field of nanotechnology?
I thought it was René van Voudenberg last week.
The lecture, and by Russell Coleman, yes, so it's a busy time.
Yeah, that's great. Make it very, very personal. I built a computer, and I was awarded the wood to go to what was then called Heifers, and books to the value of some certain thing, and I chose Feynman lectures. Lecture, he says, supposing in some cataclysm it was to be lost, and you could only pass one observation B. And what he chose was that everything is. So I read that as a schoolboy, and I knew a little bit about atoms and so on, but we'd been introduced. So, you know, a mole of stuff contains. And that was how we sort of thought about them. And I of ever seeing an atom. And then in my we acquired a scanning tunneling microscope. In fact, we acquired more than one. And it became routine to look at atoms on surfaces and actually to see atoms. And I still had to pinch myself from time to time when I saw that. And now, with aberration-corrected high-resolution transmission electron microscopy, it's absolutely routine to see atoms. And let me give you an example. Some of you may know of graphene, this sort of two-dimensional sheet of carbon atoms. And the atoms are connected by sp2 bonds, which are about 142 picometers long. And the resolution of the microscope is about 80 picometers, so getting close to half the spacing between two carbon atoms. And you can just see them routinely. And I just find that absolutely amazing.
Great. Well, I think on that note, we'll have to draw to a close. Don't forget Andrew's book, Penultimate Curiosity, coming up next January. Please do sign up. If you need to sign up to get some reminders on the sheet as you go out on the left-hand side. And don't forget the bookstall, great books there to browse after this talk. But finally, let's thank Andrew for a very interesting talk. Thank you.